Okay, this video is going to be on systems of equations, an intro of systems of equations, both graphing, solved by graphing, solved by elimination. I want to go over some basic concepts before we get into the heart of solving the problems. First, I want to talk about what a system is, okay? System of equations. All right, basically a system of equations is comparing two different lines, okay? And what we want to look at is there's three scenarios that we can have, okay? Okay, I'm going to explain each one. All right, there's three types of systems. When we talk about finding the solution to a system of equations, what we're talking about doing is finding the intersection. Okay, we're talking about finding the intersection. Now, here the intersection obviously is 1 point. And for the most part, a lot of the answers we're going to have are going to be 1 point. All right, so that's going to be some kind of coordinate. Okay, let's say 3 and 2. Okay, all right, where this is the x and this is the y. And now what's going to be asked sometimes is which, they're going to ask you for one or the other or both. Okay, if you notice here, these are two sets of parallel lines and they don't intersect. Okay, this would be no solution. Okay, because there isn't going to be an intersection. They're never going to cross, almost like railroad tracks. Okay, they're never going to cross, all right, unless another set of railroad tracks comes in. But if it's that set, they're never going to cross. This is one line on top of the other. It's the same line, okay? It's the same line, okay? And this is infinite solutions, okay? Here's why. If the intersection is where they cross, this crosses once. Well, where do these cross? Every single point, okay? So as we do these, you have to understand that concept, okay? That's the first thing, all right? That's the concept of systems of equations. The next thing you have to be able to do is manipulate an equation, okay? We're going to work on two things. Number one, manipulating to get things in y equals, and the other thing is to get x and y on the same side. So let me talk about y equals, okay? If I had something like this, okay? Let's say I had something of this nature, okay? And I wanted to get this in y equals. All right, now let me give you a shortcut. What that means is I want to get this and this away from y. Now, this goes first and this will go second. Now, as a little shortcut for you, if it's a positive 3x on this side, when it moves over to the other side, it changes. So when it moves over to this side, it changes sign. Okay, so what I'll have is 2y, negative 3x, plus 8. Now, why did I write it that way? Because we're used to writing lines with the slope first, okay? All right, now to get rid of this, I divide each part by 2. Okay, that would be getting something in y equals, all right? Let me show you another example of that. Let's say I had negative 6x, plus 3y equals 12, okay? Now, if I wanted to get y by itself, this goes first, this goes second. So when this moves over, if it's negative 6 to start, it's going to be positive 6 on this side. And then to get rid of that 3, I'm doing division. Okay? That's one example, all right? Another example of getting something by itself, let's say I had 7x minus 14y equals 28, okay? This would move over and become negative, okay? I got to keep this negative here and divide by negative 14, okay? All right, make sure you reduce your fractions. So when you have your calculator here, all right, what you want to make sure you're doing, let me get back to my menu. What you want to make sure you're doing, negative 7 divided by negative 14. Fraction to decimal, 1/2. Okay? All right, 28 divided by negative 14. Negative 2. Use your calculator, reduce those fractions. Okay? All right, that's one concept of getting things into y equals. Okay? Now, here's another concept that we're going to need to be able to do. All right? How to get x and y on the same side. Okay? If I had something like this, okay? I want to get x and y on the same side, and I'm going to show you why in a little bit. But the same concept exists. If I move from one side to the other, I want to change that sign. So in this case, I'm going to move 2x back over here. Okay? And that's all I have to do. So I moved it from here to here. Okay? Now, here's the thing. X is going to be first. Y second. Equaling a number. Okay? All right? When we want to get x and y on the same side, I'll do one more like that. Let's say I have 5y equals negative 3x plus 8. I want to move this back over, so it'll be 3x plus 5y equals 8. Okay? Another example of that would be if I had like 2x equals 7y minus 6. I would want to move this back over, so that would be 2x, negative 7y equals negative 6. So when you move things, the shortcut is change the sign. And if you want x and y on the same side, okay, what you're going to want to do, all right, is have the x first and the y second. Okay, now let's get into the two types of scenarios you could be brought into with systems. Okay, both would be solved by graphing. And let me give you a couple of different types of problems. I want to sort of split the screen here for a second and give you two types. Let's say 2x minus 7, y equals negative 3x plus 5. Let's say I've got 2x plus 4y equals 8, and let's say negative 3x plus 5y. Let's actually do 6y equals 12. Okay. Now, as you can notice, two types of equations, and they should both look familiar for you, since we graphed both of these types in the previous class. Now, what you want to do first is come up with your solutions. When you have a y equals based problem, what you're going to want to do is graph that to find the answer in your calculator. Okay? So what I'm going to do is I'm going to go to Menu, I'm going to go to Graph, all right, I'm going to delete my two equations I have in there, and what I'm going to do is I'm going to type these in, and I got 2x minus 7, negative 3x plus 5, okay? And I didn't put the x in there. Okay, and I want to draw them. Okay, now I'm gonna fix my window here real quick. Exit, draw. Okay, as you can see, that is my answer to this question is this intersection here. Okay, now how do we find that intersection? Very easy. Okay, I'll go slow for this. All you got to do is once you draw it, you go to G-solve, which is F5. And we're looking for intersection, which is this one, okay? And that tells you my intersection is x equals 2.4 and y equals negative 2.2. Okay? That is your answer. If it's written as a coordinate point, it's written like that, okay? All right? Either answer is acceptable, okay? Either answer is acceptable. Now, if I wanted to zoom in, and this is an important feature, if I do zoom and auto, it's going to make the graph sort of fit better. So sometimes if you can't find it, what you want to go to zoom, auto, okay, and that will sort of rearrange the graph for you. So there's your answer for that one. Let's go ahead and do this one, all right? Now, this is a little bit different. If you have x and y on the same side, you're not going to want to graph it. There's a lot of work entailed in getting it y equals if you have to change both. Now, what you can do, this process is going to be a little different, okay? All right, go back to your graph. We're going to go to the equation section. okay? And now what we have when we have a system is a simultaneous equation, all right? And that's the one we're going to hit. So I'm going to select F1. Now I've got two unknowns. I don't know X, I don't know Y, okay? Now, the reason why we wanted to put things, why I went over how to put things X and Y on the same side, is with this calculator, if you can arrange it so X, then the Y equals the number, you type in those amounts. So for that top line, I type in 2, 4, and 8, okay? That's my 2, 4, 8. This other one is going to be -3, 6, 12. Now, what's easy on this is we just have to solve it, okay? Which the answer there is X equals 0, Y equals 2, all right? Or 0, 2. Now, all right, what you're going to be expected to have to do, however, is you're going to have to be able to make a graph and show all this. All right, so we should be able to graph equations like that. Well, that one's easy to graph. All right, I'm going to start at -7. 1, 2, 3, 4, 5, 6, and 7. Way down here. I'm going up 2 over 1, okay? All right, and then for this one, and I would draw my line, right? And then this one I would go up 5. 1, 2, 3, 4, and 5. Down 1, 2, 3 over 1. Now, when we draw this, what would make sense is let's go ahead and plot this point as well. The reason being is this point will be on that line of both of them, okay? So I'm going to plot 2.5 over about -2.2 down. So I'm about here, okay? So if you notice, what I should do is I should draw it through all 3 points, each direction, okay? The same thing with this one, okay? All right, if you want to, all right, you should probably plot the point 0, 2, which would be right there. Now I'm going to go ahead and graph these. Now these are solved by intercepts, okay? So what I would do here is I would have 2x equals 8, all right, which would be x equals 4. Okay, and then 4y equals 8. That's y equals 2. All right, that's already there. That's good. Then this one, -3x equals 12. All right, is if I divide by -3, is going to be x equals -4. And then 6y equals 12. That's going to be y equals 2. That's already there. So in this case, here's what it would look like. This way, this way. There's my intersection points, okay? All right, and we're going to practice some of these, all right? So what you have to make your decision on is, now that I split the screen, is which one do you use, okay? All right, now, I might have something that looks like this. Let's say I had this kind of equation. Y equals 5x plus 5, okay? Y equals 7x minus 1. Okay? All right? So, what I want to do is, I got to figure out, well, which method do I want to use? Well, y equals is going to be prevalent here, so I'm going to go ahead and graph it. Okay? All right, so I'm going to go to Menu. Oh, where's my graph? All right, there it is. All right, since it's in y equals already, that's going to be easier to graph, so I'm going to delete that. Okay? I got 5x plus 5. I've got 7x minus 1. Oops. Leaving out the x's. X. X. Okay? And I draw it. And as you can see, I've got an intersection here. If I wanted to zoom auto, it's going to maybe make it a little easier to see. All I got to do is go to GSolve, intersect. I got 3, 20. That's going to be my intersection. It's going to be 3, 20. And if I asked you to graph that, what you would do would be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It would be something like this, okay? All right, that would be your intersection, okay? So when I went to go graph this top one, it would be 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5 over 1. So I know I'm going to go through all 3 of those points, okay? All right, this is a -1 here, so I'm going to do down 1, then up 1, 2, 3, 4, 5, 6, 7 over 1, okay? Once again, through all those, okay? All right, actually that's not a very good graph because of the, let me make sure I type this in right. Yep, that's what I got. Yeah, okay? So when you go to graph that, down 1, up 7, okay? All right, over 1, just connect your graph. All right, here's one, you gotta make a decision. Which one would make more sense to use? If I had 2x, okay, plus 4y equals negative 6. All right, let's say it's x minus 3y equals 7, okay? Which one would I want to do? Okay, well, since they got x and y on the same side, all right, I'm going to go in to my equation, okay, and I'm going to simultaneous 2 solutions, okay, so that's going to be 2, whoops, going across 2, all right, 4, negative 6, all right, that number is 1, negative 3, 7, all right, solve. 1, negative 2 is my answer. So, as a point, if I were graphing that, okay, all right, I would have 1, negative 2. So I know that's going to be a part of my graph. Now, when I go to graph these, that's 2x equals negative 6. So when I divide by 2, I'm getting a little sloppy here. If I divide by 2, I get x equals negative 3. Okay, and then I would take 4y, set it equal to negative 6, divide by 4, I get y equals negative 1.5, which is about right here. So notice I have 3 points in this case. So I can just draw right through there, okay? On this one, I got x equals 7, all right? Well, that's 2, 3, 4, 5, 6, and 7. Okay, and then I got negative 3y equals 7, divide by negative 3. I got y equals like, let's see what that is. It's a 7 divided by negative 3. Oops. All right, 7 divided by negative 3, and I get negative 2.3, okay? All right, so that's negative 2.3, which is here, okay? So if you notice, I've got this green point and this one, that all ties together. So that's where my intersection is, okay? So if you've got a graph, that's what you can do. Now, I want to talk about if you have to manipulate, because sometimes you're going to have examples where maybe one is in the right position and the other one is not. For instance, if I have x equals negative 2y plus 1, x equals y minus 5, okay? Now, in this case, you have no clear-cut way. You can do it numerous ways. Now, my personal opinion is bringing things back to where x and y is with the solver makes it easier. So, think about it. What would this be if it moved back with x? If it's negative 2, it would become positive 2. So this is what I would have now with that top equation. This one would move back. It would be negative y equals negative 5. So when I go to find the equation now, all right, I'm going to go into menu. That's going to be the equation 1. I'm a simultaneous. I don't know 2 of them. That's 1, 2, and 1. Then I got 1, negative 1, and negative 5. All right, and I solve it. Boom, x equals negative 3, y equals 2, okay? Once again, if you were to graph that, solve by intercepts, okay? All right, whoops, this way. Okay, let me make sure my answer was right there. All right, negative 3, 2, okay? So this one, all right, my ones I'm graphing in green would be x equals 1, because I would set that equal, 2y equals 1. All right, that first one I would have 1 for x and 1/2 for y. Okay, let me graph those in some different colors. Okay, so that would be that graph there. Okay, this one would be x equals negative 5. Okay, and negative y equals negative 5, which I would be divided by negative 1. That's y equals 5. Okay, so once again, that point that I had to start with, as you notice, that becomes my answer. Okay, now let me do another one. Okay, all right, sorry for this taking so long, but this is basically the concept of systems here. Let's say I had something that looked like this. Let's say I had y equals, let's say 1/2 x. All right, minus 4. And then let's say I had x plus, or let's say 4x plus 8y equals 16. Now, once again, could you bring the 1/2 back? Sure. Actually, let's make this a little easier. Let's make this 2. Okay. Could you bring the 1/2 back? Sure. But if I wanted to move that over, that would be 2y equals negative x plus 16, and I would divide by 2. That's y equals negative 1/2 x plus 8. Okay. So here are my two equations. Okay. And if I wanted to graph that, now this one would be, since they're y equals, they would be a graph. So exit. I'm going to go back to the menu, and I'm going to graph these. Okay, so I got 1/2 x. Oops, let me put that in parentheses. 1/2 x. All right, minus 4. Okay, let's do negative 1/2 x plus 8. Okay, and I'm going to draw. Okay, I'm going to see if I can fit this in a little bit better. So I'm going to do zoom auto. Okay. And as you can see, it works out better. So G-solve intersection, there's my intersection. It's x equals 12, y equals 2. Okay, if you wanted to write as a point, it would be this. Don't worry about graphing it in this example. I want you to catch the idea. Okay, so sometimes you might have to move back to y equals, sometimes you might want to have x and y on the same side. All right, let me go on to the final thing with systems, is understanding questions like this. Let's say I have 2x minus 4, y equals 2x plus 6. Okay, now, if I go into the calculator, you guys would say, okay, Mr. Evans, we're going to graph this because these are both in y equals. Okay, that's a great idea, all right? All right, let's do 2x minus 4. Okay, let's do 2x plus 6, all right? 2x plus 6, all right? So I'm going to draw that. Now, okay, I'm gonna do exit, let's say zoom auto. Okay, this is what I got. Now what does that look like? All right, now if I do G-solve intersection, not found. Now not found doesn't necessarily mean that it is a no solution. Now in this case, all right, as I drew it, I can clearly see that there are two lines. Remember, there are two scenarios besides this one. There are scenarios where you have parallel lines, which is no solution. There's also the scenario where you have two lines that are on top of each other. Now, here's a good rule of thumb. If you see the two lines, okay, and they give you not found and you see 2, that means it's no solution. Okay? Now, if you can only see 1 and it's not found, it depends on the graph. Okay? All right? So, in this scenario, it is my answer for this one would be no solution. Okay? All right? Now, another way to figure that out is if you look at that, all right, if I know 1, 2, 3, 4, that's where I would start that one, right? That's where I'd start that one. Now, this one would start up here. 1, 2, 3, 4, 5, and 6. So I know they're not the same line, okay? Up 2 over 1, I know they're not the same line, okay? Up 2 over 1, I know that that's going to be a no solution, okay? Now, when the ones where you have x and y on the same side, let's say I had x plus 2y equals 6. Let's say 3x plus 6y equals 18. Okay? Now this one you would say, let's go to the solver to do that one. Okay? You're right, let's go to the solver. So I'm going to go into the equation. I'm going to do simultaneous 2. I got 1, 2, and 6. The other one I got 3, 6, and 18. And I go to solve. Ooh, error. So that means I either have no solution or infinite solutions. Let's figure out which one I have. Okay, if I solve this by intercepts, that'd be x equals 6, 2y equals 6, so I would have y equals 3. Okay, so I go to graph that one in green. 1, 2, 3, 4, 5, and 6. Okay, 1, 2, and 3. Okay, so here's that first line. Now, let's say I do this one. 3x equals 18, divide by 3, all right? X equals 6. Oh, now look at that. I'm at the same spot. All right, 6y equals 18. I got y equals 3. Oh, that's the same line. So that's going to be infinite. I hope that makes sense to you. That basically I only graphed the same thing twice. Okay? What would that look like in y equals? What would that look like in y equals? Let's just do 2 more and then we'll be done with this video. All right? Let's say I had y equals 3x plus 5. All right, y equals 3x plus 5. Well, that's pretty easy to see. Same line, okay? All right, same line. Even if you had to go in and graph that, okay? I'm going to delete 3x plus 5, okay? 3x plus 5. Draw it. It's the same line. If I go to find the intersection, okay, it might find it, it might not. But you got to know that if it's the same exact thing, that's just going to be infinite because it's going to touch everywhere. It's the same thing. Okay. All right. What would a no solution look like on the other side? Let's say I had x minus 2y equals 4. Let's say x minus 2y equals negative 6. Okay. If I go in, all right, that's an x equals. All right. So I'm going to go to menu, equation. Simultaneous, all right, 1, negative 2, 4, all right, 1, negative 2, negative 6, solve, error. Okay, I got to check this out now, all right? So, that would be x equals 4, okay, negative 2y equals 4, divide by negative 2, I got y equals negative 2, okay, so here's that first line. Okay? Now, when I graph the other one, it would be x equals negative 6. As you can see, I know it's not the same line. Okay? All right? So I already know this is a no solution. Okay? But let me finish this out of y. All right? So I got negative 2y equals negative 6. Divide by negative 2, I got y equals 3. So that's 1, 2, and 3. And as you can see, these aren't going to touch. And we already knew that from the example. So, getting back to it, what you have to be able to do, a couple things. Let's get back to a summary here, all right? A system of equations is the intersection, okay? You're trying to find the intersection point. You're either going to have one, if you have two lines that don't touch, you have no solution. If you have the same line, okay, you're going to have infinite solutions. If you need to move things from one side to the other, understand that they change sign from one to the other. If you're trying to get things in y equals, you got to move that term first and then divide by the number in front of y. Okay? Sometimes it might be easier to bring everything back to x and y. Now, on the same side, if that's the case, your x term goes first, y term goes second, just like the alphabet. I know that was a long video, but I think as you start to practice it, this will get easier and easier.